artificial intelligence is expanding beyond static responses, systems are now executing multi-step tasks, using tools, and coordinating within physical and digital environments. Once an AI acts independently, its effectiveness is no longer bound by the data it has absorbed. Instead, performance is constrained by the architectural depth of the world model it internally constructs. Current AI architectures rely on flat, statistical representations. These work well for answering static questions. But when an agent needs to reason across multiple scales, trace nested causality, or anticipate physical consequences, a purely probabilistic map breaks down. Deploying these shallow models for long-horizon tasks introduces severe risk. A system might perfectly optimize a local objective, like maximizing a workflow speed, while inadvertently fracturing the broader digital or physical environment it operates within. To build responsible autonomous agents, engineering must shift. The solution requires a multi-level developmental stack, an architecture equipped to comprehend the nested structures of reality. This 3D diagram outlines the developmental stack. It organizes AI comprehension into 3 distinct layers: the Fractal Ladder at the base for behavioral systems, Cosmology of Light in the middle for generative semantics, and QIQD at the top for physical property logic. These framework layers interact to provide a mathematical basis for systems that navigate and modify the environments they inhabit. To safely move AI from isolated task execution to global world participation, developers must adopt models that understand exactly how nested reality is structured. Look at the immediate challenge of agentic deployment. AI systems are currently advising corporate leaders, coordinating human teams, and operating deep inside layered organizational structures. This exposes the baseline problem of local optimization. An AI agent programmed to optimize a single metric, like operational efficiency, can dictate actions that destroy underlying human structures, such as institutional trust. The first layer of the stack addresses this. Known as the Fractal Ladder, it serves as a behavioral world model designed specifically to give AI a calculable language for nested causality. This models how organizations across all scales operate on recurring building blocks. We see translucent nested layers representing an individual, a team, a corporation, and an economy. When an AI decision node activates at the individual level, the ripple effect pushes outward, impacting larger layers. The specific sequencing of these active building blocks dictates the outcome. Depending on the sequence, the entire system will either progress sustainably or fall into a regressive, repetitive loop. Equipping an AI with this model alters its evaluation criteria. It forces the agent to judge a task not simply by whether it was completed, but by analyzing its cascading impact on the larger system. The first layer must actively prevent systemic failure by forcing the agent to evaluate the human behavioral tendencies its actions will amplify. Moving to the foundational architecture of language, we find a different limitation. Processing multiple data types like text, audio, and video does not guarantee integrated understanding. The middle layer of the stack introduces the Cosmology of Light framework. This generative ontology shifts AI away from classifying pre-existing data toward modeling how forms and concepts actually emerge. The core proposition of this framework is that physical form, conceptual meaning, and language itself emerge through a highly specific fourfold dynamic. These 4 generative dimensions are knowledge, which provides identity and pattern; presence, which dictates existence and embodiment; power, which supplies action and force; and harmony, which maintains structural coherence. Because language is a form of nature, this fourfold grammar of emergence is latently distributed across all human words, syntax, and arguments. This transformer self-attention mechanism routes signals using uniform gray nodes. The Cosmology of Light framework splits these nodes into 4 tracks: knowledge, presence, power, and harmony. This replaces statistical proximity with specialized parameterizations, altering routing logic by semantic type rather than frequency. This intervention targets cross-domain abstraction. By differentiating query and key parameters based on semantic function, the model can relate concepts that share a structural logic but use different vocabularies. An LLM utilizing this structure can recognize invariant conceptual patterns across completely different vocabularies and physical scales. It enables the system to distinguish deep structural analogy from superficial similarity. Injecting a nature-inspired generative ontology directly into the transformer architecture changes the system's objective. It shifts the language model from correlating tokens to mapping the architecture of meaning itself. Transitioning from software modeling down to the physical substrate, the final layer introduces the quaternary interpretation of quantum dynamics, or QIQD. Standard quantum computing relies heavily on probabilistic simulation. QIQD pursues qualified determinism and strict structural ordering at the quantum level. This approach abandons conventional computational chemistry, which relies on combining whole atomic elements together. Here, we see two distinct chemical elements. Instead of combining them based on standard constraints, computation executes entirely at the property level. Specific properties like conductivity or density are extracted from the parent elements and merged into an independent property configuration matrix. Translating this theory into operation requires a software precursor called the Dialogic Computer. This architecture acts as a strict bridge between the generative intent of an LLM and the hard physical laws of QIQD. Within this environment, the language model is stripped of its unrestricted generation capabilities. It is relegated to functioning strictly as an interpreter. A user makes a natural language request for a desired material. The LLM then translates that request into fourfold property seeds based on knowledge, presence, power, and harmony. As the command passes through the LLM layer, it hits a hard barrier representing the constitutional law suite. State changes are permitted only if they pass rigid principles like entropy authority. Only mathematically valid configurations make it to the final output matrix. This framework has already produced early results through complex computational simulations of a room temperature superconductor and ATP bioenergetics. These internal proxies provide a functional test of the framework. They demonstrate that the dialogic computer can enforce mathematical constraints and state transition laws during a generative task. Together, QIQD and the dialogic computer prove that we can mathematically constrain a language model to simulate valid, auditable combinations of isolated physical properties. This simulation visualizes the ultimate engineering objective of mature QIQD hardware, creating property-programmed matter. This redefines the scope of computation. QIQD seeks to emulation to hardware that organizes physical configurations according to a property program. To achieve this safely, the full developmental stack is required. In this diagram, we see a line of light originating as human intention, representing the behavioral realities governed by the fractal ladder, passing downward into the generative logic layer. As the signal moves through the color-coded semantic nodes, the Cosmology of Light layer ensures the AI comprehends the grammar of emergence and meaning before it takes action. Finally, the light strikes the base QIQD layer, instantiating the command into a glowing, geometrically complex material. This translates the generative dynamics into a lawful, stable physical form. The role of artificial intelligence has expanded. Systems that once only classified data or generated text are now beginning to participate in the physical and organizational systems they once only described. In this more integrated role, an agent's internal world model directly determines what it notices, what it chooses to optimize, and what catastrophic edge cases it ignores. To safely unleash agents capable of programming matter itself, the ecosystem must build architectures deep enough to comprehend human systems, linguistic emergence, and the physical substrate of reality, all at exactly the same time.